Hello everyone, let's do some numericals based on defects of eye. Example 1 says a far-sighted person cannot see objects placed closer to 50 centimeter. So this person cannot see anything placed before 50 centimeter. Find the power of the lens needed to see the objects at 20 centimeter. So what is given here is this case the person can see only from a point n such that the distance of the point n from the human eye is 50 centimeter. So this is given as 50 centimeter. The question says what lens should be used so that the person can see an object placed at a distance of 20 centimeter from the eye. So we need to find what lens is required for this case. We have learned in theory class that in case of far-sightedness we need to use a convex lens. So here the lens required is a convex lens. But keep in mind that this convex lens will not form the image of the object on the retina directly. Rather, this convex lens forms image of the object at the point n, because from the point n the eye can see clearly. So keep in mind that any optical instrument will not form the image directly on the retina. Rather, the optical instruments or the corrective lenses would form the images at the point from where the eye can see. So in this case, this object forms image at the point n, because from the point n the eye can see it clearly. Therefore, in this case, the image would be formed because the eye is seeing from the point n. Here keep in mind that u is equal to 20 centimeter and v is equal to 50 centimeter, and the sign convention, the light from the object is going from left to right. So light is going from left to right, but we are going from right to left like this. So by sign convention both u and v are negative. So putting it back here, from lens equation we know that 1 by f is equal to 1 by v minus 1 by u is equal to minus of 1 by 50 minus of 1 by minus 20, that is equal to minus 1 by 50 plus 1 by 20. It implies 1 by f is equal to minus 20 plus 50 by 20 into 50, that is equal to plus 30 by 1000. So focal length from here would be equal to 1000 by 30, that will be 33.33 centimeter. Keep in mind that u and v are in centimeter. So this is the required focal length. Power is given as 1 by f, that's 1 by 33.33 centimeter. But keep in mind that to find power, f should be in terms of meter, not centimeter. Therefore, rewriting this becomes into 10 power minus 2. This goes on top. It becomes 10 power plus 2, which is 100 by 33.33 is equal to 3 diopter. As seen here, the focal length is positive, which means it's a convex lens or a converging lens. Example 2 says a person can see clearly up to 3 meter only. Prescribe a lens for his spectacles so that the person can see clearly up to 12 meters. In this case, it is short-sightedness because the person can see only up to 3 meters. So, if we draw a diagram for this, then the person can see only up to this point. We call as far point. The distance from the eye to this is 3 meter, but here we need to find, or the person should see an object placed at a distance of 12 meter. So this is the object placed at a distance of 12 meter. Question says what is the corrective lens required. So you learned that it would be a concave lens. Again here, this object at point O would form an image not on the retina directly, rather this forms an image at the point F, because from the point F the eye can see clearly. So keep in mind that in all the cases the corrective lens would form image at the point from where the eye can see clearly. So from here it will be focused like this. So in this case the person needs to look at the object placed at the point O. So here U is equal to minus 12 meter by sign convention, and then V is equal to minus 3 meter. Now keep in mind that the distance between the lens and the eye is so small that even though the distance of 3 meter or 12 meter is given from the eye, we are using it for the lens because the distance between the lens and eye is very, very small. So basically this also means distance from the lens only. So we need to find the focal length. 1 by F is equal to 1 by V minus 1 by U, that is equal to minus of 1 by 12 minus of minus 1 by 3, that is equal to minus 1 by 12 okay, here it is minus 1 by 3 is corrected, plus 1 by 12, that will be minus 12 plus 3 by 3 into 12, that is minus 9 by 36, or F is equal to minus 36 by 9, that is minus 4. In this case both U and V were in meter, therefore even this would be in meter only, so it is minus 4 meter. Observe here that focal length is negative, which means it is a concave lens. Next, to find the power is given by 1 by F. So the power is 1 by F, that will be minus 1 by 4, so that will be minus of 0.25 diopter. Example 3 says a presbyopic patient has a near point as 30 cm and far point as 40 cm. Find the dioptric power, or just in simple language power, for the corrective lens for seeing near objects. Now here it doesn't say at which point the object is placed, but rather what is given is this person has a range of vision such that the person can see only between these 2 points. So the person can see only between distance of 30 cm to 40 cm. But not anything here or here cannot be seen. The question says what is the power of the lens required to see nearby objects. So that would basically means that we learned that for normal human eye the near point is at a distance of 25 cm. So question says indirectly that what is the lens required to see an object placed at this point. So here U is equal to minus 25 cm, and here this object would form image at the point N. not point F, because point N is close to near point. Therefore here V is equal to, it is minus 30 centimeter, not this value. So the focal length is given as 1 by F is equal to 1 by V minus 1 by U, that is minus of 1 by 30 plus 1 by 25 is equal to minus 25 plus 30 by 25 into 30 is equal to 5 by 25 into 30. F is equal to, it will be 25 into 30 by 5. So it is equal to 5 ones are 5 5s are, that is equal to 150 centimeter. So it's a convex lens. The power in this case, power is equal to 1 by focal length, that's 1 by 150. Observe that in this case it is in centimeter, so into 10 power minus 2 would be in meter. 10 power minus 2 goes on top, it's 100 by 150 is equal to 2 by 3 diopter. So this is the required power in this case to see an object at the near point. That's the answer. Example 4 says a person cannot see an object lying beyond 80 centimeter, which means the person can see only up to 80 centimeter. That means it is a myopic eye, or it's a myopia defect, whereas a normal person can easily see the object distant 160 centimeter. Find the focal length and nature of the lens required to rectify this defect. Now, what is given here is this person with a defective eye can see only up to a distance of 80 centimeter. So for the far point for this person is 80 centimeter. This person cannot see anything beyond 80 centimeter. But the question says a normal person can see up to 160 centimeter. Now here question says find the focal length and nature of the lens required to rectify this defect. Which means here what is meant here is that a normal person can see an object placed at a distance of 160 centimeter. Question says find the nature of the lens required to rectify this defect. So here it means that we need to find a lens which would help the person to see the object placed at the point O. Since the person cannot see beyond this point, it's a myopic defect. So the lens required would be a concave lens like this, so that the object would be the point O and light from the object would fall on this lens, and then this lens would form image not on the retina directly, rather this image or this object would make image at the point F, because from the point F the eye can see it clearly, so that the image because of the two is seen on the retina. So it works in two ways. In the first case, the corrective lens forms image at the point F from where the eye can see it. So in this case U would be minus 160 centimeter, and here V is equal to minus 80 centimeter by sign convention. Therefore what we get here is 1 by F is equal to 1 by V minus 1 by U, that is equal to minus 1 by 80. It becomes plus 1 by 60, because minus is plus, that is equal to minus 160 plus 80 into 80 into 160. This is minus 80, and we can write this as 80 into 160. So from this, 80 gets cancelled. Therefore, the focal length would be, take its reciprocal, minus 160 centimeter. So this is the focal length. As seen here, the focal length is negative. It means the lens what is required here is a diverging lens. We know also as to what the lens is by theory classes. In case if somebody is not able to recall what the lens is, then don't put any lens here. Instead of this, you can draw the effective eye and just put a block like this. So in case you're confused as to what it is, then put a block, and then by knowing the answer, we can know what the lens would be. Example 5 says, a long-sighted person has a least distance of distinct vision of 50 centimeter, which means the person cannot see anything placed before 50 centimeter. He wants to reduce it to 25 centimeter. So what kind of lens should he use and find its focal length? Again, here it's a case of long-sightedness where the person cannot see anything placed before 50 centimeter. But the question says what lens he should use so that it reduces to 25 centimeter. So what it means here is that, as in the earlier cases, if you have a lens like or a human eye which is defective, this person can see only from a point P whose distance is 50 centimeter from the lens, from the human eye. Question says he needs to reduce it to 25 centimeter. What it basically means is that if an object is placed at this point with a distance of 20 centimeter, the person should be able to see it. Now, this person cannot see without the corrective lens. Therefore, here we need to use a corrective lens, and that should be a convex lens. Again, here the person is looking at this object O. So that's what we need to find the distance. Again, as seen in the previous numericals, this object O, light from the object O falls on the lens, and this lens forms image at the point P from where this eye can see. So here U is equal to minus 25 centimeter and V is equal to minus 50 centimeter, because the corrective lens, that is this convex lens, forms image at the point P. By using lens equation, 1 by F is equal to 1 by V minus 1 by U, that is equal to minus 1 by 50 plus 1 by 25, that is equal to minus 25 plus 50 by 25 into 50 is equal to 25 by 25 into 50. From here this gets cancelled. We want F, so here we have 1 by F. Therefore, if we take reciprocal, F is equal to 50 centimeter. If we need to find the power, because that's what most questions will ask, power is equal to 1 by focal length. It's 1 by 50 in terms of centimeter, so into 10 power minus 2 would make in terms of meter. So 10 power minus 2 goes on top, it becomes 100. So power is equal to 100 by 50 is equal to 2 diopter. So this is a required answer. Example 6 says, to read a poster on a wall, a person with defective vision needs to stand at a distance of 0.4 meter from the poster. A person with normal vision can read the poster from a distance of 2 meter. So what should be the power of the corrective lens? So first and foremost, understand what is given here. For example, if you look at this as the poster on the wall, a person with a defective eye, this person can see it from a distance of 0.4 meter. Imagine that the person is gone somewhere behind like this. This person cannot see from here because he can see only from distance of 0.4 meter. That means that the person has short-sightedness. Again, what is given here is a person with normal vision can read the poster from a distance of 2 meter. So if this is the poster, a normal person can read from distance of 2 meter. Can read from here. So question says, what should be the power of the corrector lens? Now to understand this, imagine that if this person here walks up to distance of 2 meter, this person cannot see the poster because he has short-sightedness. So in this case, if you want to see the poster also, so imagine the person is somewhere here. He is at this position. If the person wants to see the poster, he can't see it because the person can see only up to 0.4 meter. But here, the person needs to look at the object at 2 meter. So here, u is equal to minus 2 meter because the person should look at the object at a distance of 2 meter. And the sign convention, if you use a corrective lens, then u will be negative. And also that corrective lens, as seen in the earlier numericals, would form an image such that the image is formed at a distance of 0.4 meter from the eye, because from there the eye can see it clearly. But by sign convention it will be negative. So 1 by f is equal to 1 by v minus 1 by u, and that is equal to 1 by f is equal to minus 1 by 0.4 plus 1 by 2. It will be minus 2 plus 0.4 by 2 into 0.4 is equal to minus 1.6 by 2 into 0.4. So it will be 0.4 ones are plus 4s are, that will be minus 2 because there is 2 here. So 2 ones are 2 2s are, it's minus 2. But what we want is f, not 1 by f. So from here f is equal to minus 1 by 2. In the numerical, both u and v were in terms of meter. Therefore, even this focal length would be in meter. So it will be minus half or 0.5 meter. The power would be 1 by focal length, which would be here as given here. This is 1 by f, that is same as power only, that is minus 2 diopter. So this is the required answer.